Hey everyone, and welcome. Today, we're going to do something a little different. We're going to take what is probably the very first line of code anyone ever writes, and we are going to completely unpack it. We're going to see the absolutely incredible technological symphony that has to happen just to get two simple words to show up on your screen. So let's pull back the curtain and see what's really going on under the hood. And here it is. Print hello world. You know, for almost every programmer out there, this is a rite of passage. It's that first successful handshake between you and the machine. But its beautiful simplicity, it's kind of an illusion. This one single line of code is just the tiny, visible tip of a massive and deeply complex technological iceberg. So that's the big question for us today, isn't it? What really happens when you hit enter? We're going to peel back every single layer of abstraction. I mean, everything. From the actual silicon chips in your computer all the way up to the text that appears on your screen, just to understand the entire stack of dependencies that makes this one simple command even possible. So here's our game plan. We're going to start at the bottom with the hardware. Then we'll move up to the operating system, which acts as this great translator. From there, we'll get into the Python engine itself, talk about your digital workshop, and then finally, we'll put it all together and trace the entire journey from a piece of silicon to your screen. First things first, hardware, right? Before you can write a single line of code, you need a physical machine to do it on. And choosing that hardware, well, it's not really about running a simple script today. It's a commitment to your own future. It's about buying the machine for the kind of code you dream of writing tomorrow. Just look at how your own ambitions really shape what you need. If you're an absolute beginner, yeah, 8 gigs of RAM is totally fine. But look over at the future data scientist. You're talking 32, maybe even 64 gigs. And here's a really key takeaway. For things like data science, your performance is often limited by your memory, your RAM, not your CPU. So investing in more RAM is going to give you a way bigger boost than a slightly faster processor. Okay, so you've got your machine. But how does your code actually talk to it? How does it make the metal and silicon do things? Well, that brings us to our next crucial layer, the operating system. This is the master software that basically breathes life into the hardware. It's the great translator. You know, the OS is just this brilliant layer of, well, abstraction. What that really means is it shields Python from the mind-boggling complexity of every different graphics card and keyboard and mouse out there. And this is precisely why your Python script doesn't care if you're on a Windows PC, a MacBook, or a Linux box. Your code talks to the OS, and the OS handles all the messy hardware details. It's this design that makes Python so wonderfully portable. Now, inside the world of operating systems, there's this really critical distinction you need to know about, 32-bit versus 64-bit. So what's the big deal here? Just look at that memory limit. A 32-bit system can only ever use a maximum of 4 gigabytes of RAM, period. If you have any aspiration at all to work in data science, where your data sets can easily be bigger than that, well, a 32-bit system is a non-starter. It basically closes the door on that career before you've even started. Okay, we've got our hardware, we have our OS. Now we need the engine that actually runs our code, and that's the Python interpreter. This is the actual program that reads your code, understands it, and then executes it, one line at a time. So you open up your terminal, you type the word Python, and you hit enter. And poof, like magic, the Python interpreter starts up. But wait a second, how? How does your computer's terminal just magically know where to find that one specific program among the hundreds of thousands of files on your hard drive? Well, the answer isn't magic. It's something called the path environment variable. The easiest way to think about the path is like a treasure map for your command line. It's just a simple list of folders. And when you type a command, the shell just goes down that list, systematically searching through each folder, looking for a program with that name. And this is exactly how it works. You type Python. The shell checks its map. If it finds it, boom, it runs. If it searches every folder on the list and comes up empty, well, that's when you get that infamous command not found error that drives every beginner crazy. Understanding this is a true rite of passage. It's when you go from just using a computer to really starting to understand how it works. All right, Python's installed, and our computer knows where to find it. Now we need a place to actually, write our code. This is your digital workshop. And it can be super simple, like the command line and a basic text editor, or it can be a really sophisticated, full-blown integrated development environment, or IDE. So why bother with a fancy IDE? Honestly, it all comes down to the feedback loop. With a basic editor, you have this slow loop. You edit your code, you save it, you switch to the terminal, you run it, and only then do you see if you made a mistake. It's slow, it's clunky. But a modern IDE, it gives you an instant loop. You type, You immediately see an error and you fix it. The feedback is right there, right now. And that's why an IDE is so incredibly powerful, especially when you're learning. It really does act like a silent tutor. It gives you this kind of cognitive scaffolding. It catches your little syntax mistakes in real time, and that lets you offload the mental burden of memorizing perfect grammar so you can focus on the big picture, solving the actual problem you're trying to solve.
All right, we have assembled all the pieces. We've got the hardware, we've got the OS, we have the Python interpreter, and we've got our IDE. So now, let's put it all together. Let's trace the complete journey of our command, from your fingers on the keyboard to the final output on the screen. First, let's just do a super quick breakdown of the grammar. Print, that's the name of a function that's built right into Python. The parentheses, that's how you call or invoke the function. Hello world, that's the actual data, a piece of text we call a string that we're passing to the function. And those single quotes, they just tell Python where the string starts and where it ends. Simple as that.
And so, here it is, the grand finale, the full journey. You type the command, the OS uses its path map to find the Python program. That program, the interpreter, gets loaded from your SSD into fast RAM. The interpreter then reads your code file, checks it for correct grammar, and finally it executes the print function. That function tells the OS to display the text, "Hello World," in your terminal. It's this beautiful, multi-layered dance. Of course, it doesn't always go that smoothly, does it? Sooner or later, probably sooner, you're going to see something that looks like this. A scary block of red text, a traceback, a syntax error. And when you're a beginner, this can feel really intimidating. It feels like the computer is just yelling at you for making a mistake. But I want you to try and reframe this. A traceback is not failure. It is communication. It is the Python interpreter giving you the absolute most precise, helpful feedback that it possibly can. It tells you the file, the exact line number. It even points to where it got confused. You see, learning to code is about learning to speak Python, sure, but it's just as much about learning to listen to what Python is telling you back. So the whole point is this. Print hello world is not trivial. Not at all. It's a testament to the successful integration of every single layer of the modern tech stack, from hardware engineering and operating system design to language development. To execute this one simple line of code is to literally stand on the shoulders of giants.
And that really brings us to the end. We've unpacked the profound complexity that was hidden inside this one simple command. So it kind of raises a question for you, doesn't it? Now that you've seen what it takes just to make the computer say hello, what are you going to build with your next line of code?